Welcome to the Cyber Business Podcast, where we feature top founders and entrepreneurs and share their inspiring stories. Now, let's get started with the show.
Matthew Connor here, host of the Cyber Business Podcast. Today, we're joined by Steve Orrin, Chief Technical Officer and Senior Principal Engineer at Intel Fed. Steve, welcome to the show.
Thanks for having me today, Matthew.
Oh, thanks for joining us. Before we get too far in, a quick word from our sponsors. This episode is brought to you by cyberlinks.com. That's cyber, Lynx.com. Do you know if a hacker's in your system? Most people and most companies don't until it's too late and the hacker's already done damage. A hacker's job is to bypass your security, so companies need a way of knowing when someone's gotten past theirs. That's where Cyberlinks comes in. We've partnered with the best cybersecurity companies in the world to be able to provide our clients with the best solutions at the best prices. So whether it's managed SIEM, SOC, EDR, MDR, XDR, you name it, we'll help you find the right solution at the right price. Find out more at cyberlinks.com. That's cyber, Lynx.com. And now back to our show. Steve, so what's it like being the Chief Technical Officer and Senior Principal Engineer at Intel Federal?
So Matthew, it's a good question, and it's actually a fascinating role because it's sort of like three parts. A large part of the job is really working with the federal government and the broader ecosystem, so the DIB, to understand their needs, their requirements, help them adopt the right technology, the right architectures, the right features within both our hardware and our ecosystem of OEMs and software providers that leverage Intel capabilities to get the most for their mission and the enterprise. So there's an external facing part, which is really helping the federal government do the best with the technology they have and plan for what's coming in the future so they can purchase and acquire what's needed to make the mission successful. The other half of the job is translating those requirements, those needs, and those mission environments and the special things that government needs for its broad scale enterprise back to our business unit, so that as we're building and designing and researching the next generation of hardware, firmware, and software and the capabilities that ride there, that we're meeting the government where they'll be and where they're going. And so there's sort of a two-directional aspect of helping the government adopt things, translating those requirements back to the BUs, and then translating the capabilities we have to the government. So it's a bi-directional sort of function of helping both sides. And then the third part is where we can get to do some interesting innovation. Because as you know, from your background, not everything that you can buy from commercial off the shelf is going to fit into some of the mission and enterprise requirements, whether it be just the sheer scale of the government computing environments, the security or the elevated security requirements, or some of the form factors for embedded and mission platforms. You know, planes don't operate the same way as laptops. Right. And so being able to do some customization, do enhance COTS or modify things or do research onto new areas that could become COTS in the future, but right now it's a specific government need. And so we get the opportunity to do some really interesting innovations, some pathfinding, some core research, sometimes funded by the government, sometimes funded by the DIB or in collaboration with them to achieve those future goals. And one of the interesting things about the government and working with the government is that it is, in some respects, a macrocosm of the private sector. You want to talk healthcare and insurance? Well, the VA is one of the largest health providers in the world, and it's got the largest insurance provider in the world. So they have the same problems that a Blue Cross Blue Shield or a Cigna or others would have, just at a bigger scale and with enhanced security. Yeah. Similarly, financial services, CMS or an HHS is probably the largest payment system in the world. So you get a lot of the same application problems that you'd find in the private sector, just with an increased scale or a small form factor or controlled environments, extra security. So it's really good to be able to figure out, well, where's the government going and how can we take those products that work for the private sector and adopt them into the specialized environments or the size and scope that the government has. But the other interesting thing is that we find in many cases, the government is a vanguard for what commercial will need. So especially in the security domain, the threats that the government is dealing with today, financial services is going to see those threats and be recognizing that risk in the not too distant future. So if we can build for the government and make it good enough for them, you'll start to hear the same requirements coming out of financial services and other regulated and critical infrastructure industries. And a great example of that, FIPS was it for a long time back in the 90s and 2000s was purely government only. Now you can't do financial computing without seeing that requirement in any one of their procurements. They want FIPS as well. They want that as an industry-wide standard, and it's global standard now. And we see that kind of trend continuing, whether it's advanced detection capabilities, network security. You find the government often, especially in the security, but in other scale areas as well, is driving the industry just a couple of years ahead.
Yeah. And when I think that's really fascinating because I think people don't realize that is what's happening, and it's out of necessity too, because the federal government is, the kind of the largest attack sector, and it is the most attacked, and so it's the most high value target out there, and the numbers are absolutely insane as to the amount of attacks that they undergo or attempted attacks every single day, and I think it's really hard to fathom the scope of of their attack, vector, how big it is, how much you have to defend, and so they have to be, kind of cutting edge, and which is really interesting because that is the last thing you think of when you think government generally is cutting edge. Maybe NASA was, you would think NASA, yep, they're having to be cutting edge because it's NASA, right? It's, cutting edge technology. But regular government, as you say, things like, the anything, the VA is probably the last thing you one of the last places you'd expect any sort of innovation, right? And yet, when it comes to security, has to be. So how is it? I think there's tons that we can talk about, and I'm really excited to when it comes to the, security for the government, how that works and flows down to the commercial sector. But I think what's really fascinating is AI and cybersecurity and where that's going and how that bleeds in. So you're in a really unique and cool and fun spot. So I'm gonna pick your brain as much as you'll let me, because I think this is such a unique opportunity. I don't want to waste it. So when it comes to Intel and the government and cybersecurity and AI, kind of where do you land here, in your perspective? Where is this going? What can we look for? I mean, there's a million things I want to ask you, but I gotta stop and form a question, so I'm gonna leave it at that.
Okay. So I think one way to look at that is you have to look at AI and cybersecurity as sort of two or three sides of a coin. I know that's a three-dimensional coin, but let's stick with the metaphor here.
Yeah.
There's the first question, which a lot of, especially in this industry globally, everyone is adopting AI faster than they can secure it. So the first question you ask is, well, how do I secure my AI? And what does that mean? The flip side of that coin is often asked within the CISO organizations and the operations side is, how can I leverage AI to enhance my cybersecurity? And then the third face of that coin, or maybe the edge of the coin, is how do I protect myself from AI-enabled adversaries? And so those are sort of, you have to look at it from those three dimensions. And maybe we have to come up with a better metaphor of a three-sided a die or something like that. Is how do I balance the risk of AI the risk of AI in my organization, using and benefiting my risk reduction with AI, and then also realizing that for everything we're doing, the adversaries are doing, and maybe even faster to adopt. How do we protect ourselves? So let's start with the first part of that. Just, and I'm not going to go into, we could spend hours talking about this. It's a fun topic. One of the key things is you have to recognize is that AI isn't a piece of software that you can just deploy and protect like other applications. First of all, there's a life cycle involved. AI starts with data, and it's a consumer of data at incredible scale. And so understanding how do I protect my AI from the very beginning? And that's going to be this tried and true methods, process, people, technology. However, it's applying it and that governance model across the whole life cycle. So where did the data come from? How did you govern that data? How did you inspect it or make sure that you were getting good data in the beginning? There aren't biases or other things, malicious code in there. Yeah. What happened to the data and the algorithms and the models as it's being trained? Now you're moving from the training to the tuning phases. So every step of that process needs to be addressed from a risk management perspective. And so your CISO organization, the security operations teams needs to be thinking about all the aspects, because if all you end up with is an inferencing algorithm you're going to deploy, it's a black box. And you have no idea what intrinsic risk and intrinsic vulnerabilities you're bringing to the table that you're now going to have to secure. Once you get there, then you say, okay, now how do I protect this going forward? And that's another often common mistake is, okay, we're going to do a bunch of stuff. We're going to throw in a guardrail. We'll put up a little firewall and boom, we're done. And no one is actually actively monitoring, is the AI still good? Or has it been, are there people doing injection attacks or people manipulating the infrastructure? So there's a continuous monitoring. And again, it's a term that people use. Zero trust applies to AI. It's just a different way of applying it. And there's actually conferences this year that are starting to address, the nuances of, well, how do you do agentic identity? And how do I detect hallucination or drift? These are all part of the overall story, which is thinking about AI from an ongoing perspective, a continuous monitoring, continuous validation, and being able to have the right controls in place where if you need to push the panic button, that you have a rollback to a known good state, that you're monitoring both the operational environment of the AI as well as the inputs. It reminds me, oftentimes, I'm in these sessions talking to some of these security experts and these AI experts, and it reminds me of the old web application days where everyone was worried about protecting the web server from OS attacks, but no one was looking at the input field.
Yeah.
And guess what? All the attacks were coming in through the inputs.
Yep.
Cross-site scripting, SQL injection. So now we have new terms. It's prompt injection. It's the same problem.
Same
We're
thing.
reliving the past. So the guidance and really when it comes down to is understanding is how do I secure my AI throughout its life cycle and how do I protect it once it's deployed? Because the other thing is that AI, it's great if you have a chat GPT, it's a one interface, great. But what we're seeing is AI is being distributed into the things, into the systems, into the sensors, into the drones, into the planes, into your car. And so how do I protect it where it lives? And so making sure that you surround that AI with the right controls, the right security, the right validation attestation to make sure that it's always operating in a known good state with a known good behaviors. And so it's really looking at all aspects of AI. So that's part one is you need to look at AI from the holistic perspective and apply the risk management through every one of those phases and then constantly monitor and validate that everything is still what you expect it to be. When it comes to AI and cybersecurity of enhancing it, this has been an exciting time. It's also been where there's a lot of great ideas that actually don't meet the reality. I don't want to call them snake oil, but let's just say that it sounds great that I can use a large language model to detect every new malware that ever comes out. But the reality is that you have to remember how AI works. AI works by consuming large amounts of data that's very similar to be able to create those weights and patterns and parameters to be able to then identify something new. But it's not really identifying something new. It's identifying something that looks a whole lot like something I've already trained on.
Yeah.
A brand new APT, how many examples of that do you have? One. So there's not a lot of data to train on. And so a lot of the approaches that people took early on, which is, we're going to use AI to detect the next ransomware that no one has ever seen, don't actually succeed because you don't have the training set to really do that kind of detection. Or you have to take a different approach to the training set, which we'll get to. So the key thing is to understand where the best place to apply AI. And really, it comes back to why do we use AI in the first place? What is the benefit of AI? For an enterprise, again, not for the consumer. For the enterprise, it's about efficiencies. Mm-hmm. So where are we the least efficient? In the day-to-day firefighting that most IT organizations do. It's not the esoteric 10% time of an APT no one's seen. It's the 90% of the stupid stuff, of the constant firewall hits, ransomware that we've seen 400 times, misconfigurations, that kind of stuff. And then the triaging and managing and patching and automation, all the things we do that are sort of sucking up all of those limited resources that most IT organizations have. If I could automate that, if I could apply AI to the mundane, I free my resources up to go after those really interesting. And by the way, they'll be happier because they love to go after the interesting stuff, the 10%, the 20% no one's seen before. But if you could automate the 80%, or at least reduce the amount of load by applying AI machine learning to those processes. And these processes, what's good, there's lots of data on it.
Yeah.
I've got control sets. I've got lots of data from all my SIMs. I can train on that and then say, okay, for these kind of things, let the AI have it. There is a little thing that someone's got, this is a cultural problem because most people are worried about giving the keys to the kingdom and not having humans in the loop. And my philosophy is for the stupid stuff, for the mundane or the 80%, it's okay if the CEO leaves email for 10 minutes. If something does break, something will break. It always will.
Yeah.
But that happens normally. We usually say, well, that's human error. We accept that as a risk. We'll deal with it. AI error, we don't really accept that as a risk. It's the same risk.
Yeah.
We just have to be able to put in the mitigations that if something does go, if it patches something and breaks an application, we have processes to undo that. But what you've done is you've gotten a massive amount of efficiency by automating and speeding up the process of dealing with those things. And then you have these other controls to deal with the edge cases. Now you freed up your limited budget to go tackle the hard problems or the next risk on your roadmap. So that's one major area where AI can really transform IT security operations. And that also applies, by the way, to DevSecOps, to the development process, is automating a lot of the things that are just the rigor every day or the firefighting so that you can free up your resources. So that's part one. The other area where we've seen some really interesting use of AI for those really unique things is not, again, trying to detect the thing that we've never seen before, but it's applying it to the operational environment, looking at what is a baseline, using AI to understand what is normal. So that you may not be able to tell if it's a new APT, but you can use the AI to detect this thing doesn't fit into my my inferencing of what I think is if it's normal. It's outside the range. Now you can go say, okay, is that an APT or did someone just upload some code from the DevOps team that wasn't validated and it started doing wonky things? Yeah. That is a good use of AI as well. And that will help you catch those things you've never seen before. But it's only because you have a really good understanding using the AI, and it's not just AI in the more generative side of the camp. It's machine learning, it's statistical probabilities, it's all the parts of AI to understand what is normal. And then you can see the aberrations pop up more easily. And you may not know it's an APT, but now you can take that freed up team we talked about earlier and go put them on that task. And so we're seeing some innovative uses of AI. We can call it sort of an indirect approach to detecting those APTs. And so that's an exciting area. And we're seeing there's a lot of companies out there sort of looking at innovative ways of using AI. But I think the ones that, we've seen some acquisitions in the space, the Torque and some of the others are using AI to automate the cybersecurity processes. And those are exciting things to watch.
Yeah. And I think another area and kind of as you go down, and to the end user, where the things what I get really excited about, and I think you really nailed it with that 90% of the easy stuff, if you will. And I look forward to products like Darktrace, where they're using machine learning to help the end user, let's say with their email. Makes perfect sense, right? To have that. That is exactly what you want to use AI, and the kind of AI, where people are slapping on an LLM to an existing security product, not necessarily the right thing. You just bolt it on there. That's where you start to worry, like, crap. But I think when you use the right kind of AI in the right way, and it's targeted to where, it does know, it understands how Jane writes email. And suddenly Jane's writing a very different email and sending out 600 of them at 2 o'clock in the morning. And Jane is usually not working at this. Got it. Right. Yeah. That's the kind of stuff where it's like, and you see it and you get to kind of see the future. And I'm looking forward to the day where, the one of the things that really kind of ticks me off is how you have these cyber criminals going after the elderly population, and they're just so easy to trick. Yep. I can't wait I know this is going to be a hot button topic, but like for Siri to be able to listen to your call locally on your phone and be like, Matt, this, senior Matt, right, at 80, this is clearly a scam. Microsoft is not calling you. I'm going to go ahead and hang up on them now. Okay, great. That sort of stuff where AI, fits in so easily to kind of combat the bad guys. I think that's the kind of stuff that I really get excited about, where it can help, on the cybersecurity side, it can help on the user side. Those things I think are going to be really fascinating.
Oh, absolutely. And I think, taking that a step further, wouldn't it be great if the AI was on the telecom network and that call never got to the senior? That would be better. Because this happens to everyone's grandparents. They get hit.
Yeah.
Or parents, depending what generation you are.
That's such a great point. Because then look, if it's on the telecom network, then all the BS texts, right? Like, okay, this guy's sending out 12,000 texts a day or 5. We're just going to shut that down. Right. Yeah. Fantastic. Because they're all BS scam texts. Boom. Oh,
exactly.
Brilliant.
And just notifying me that it's spam. I still have to deal with this. So can we move that shift left, move it further up the food chain?
Yeah, brilliant.
Absolutely. I think one though I want to pick on something you mentioned about where throwing an ALM could be useful. And I've seen some bigger companies do this that have the money to invest. I'll pick on CrowdStrike example, but several others.
Yeah.
They're not using the AI to automate your cybersecurity. They probably are as well. But one of their big innovations from last year was they included a AI chatbot for the operator, for the
Yeah.
one who uses their products,
Yep.
to help them. First of all, companies, large security companies, whether it be CrowdStrike or Palo Alto, have a myriad of products. And typically an IT organization has 70 to 150 security products that they have to manage and learn and train on. And there's churn and there's, do you remember how to use all those? Having that AI chatbot be able to help augment that. So you would say, hey,
That's
I've got
great.
this event. What do I do about it? Or
Yep.
what was that network IP address that we just patched the other? Like being able to have something interactive means that they're not picking up the phone and calling somebody. That's an efficiency.
Yeah.
And so seeing the LLM, same way we use chatbots to help automate customer service, we're actually seeing AI chatbots help automate the process of interacting with products so
Yeah.
that you reduce the amount of time you spent trying to track down a problem or track down an answer because the AI is trained on all of the products you have and all the data sets you have. It actually, we've seen, I've played with the product. It's really cool that it allows me to sort of ask questions like, hey, I've got a little hit in my sim here. What control did we use last week? Apply that. Done. I don't have to go look into any dashboard. I never had to write a line of code. Okay, we want people writing lines of code, but it allows you to be able to automate a lot more of that process, even with a human operator. And I think that is a powerful way of using AI, again, for the efficiency, not trying to catch something that no one's ever seen before.
No, 100%. I mean, and I really love that. CrowdStrike did a great implementation of that. SentinelOne's really
Yes, that's
good.
another one. Yep.
Same thing. It's a brilliant use of an LLM in such a great way and it really does provide such great efficiencies. And it's exactly what you want. And it's seeing things like that. Not to beat up on Microsoft because we all love Microsoft to death. But you see, it's early stages for Copilot, but you see things like that where you can see the future. It's there, like okay, this is gonna be a great thing when it can finally do what you want it to do, right? When you're like, great, create this presentation this way, and it actually does it. That's gonna be really great when it kind of matures a bit. But I think going onto the security side, CrowdStrike and SentinelOne, they really knocked it out of the park first time at bat. I think
Yep.
it was a home run for both of them there. Those are just solid uses of an LLM in a cybersecurity product. Yeah, totally agree.
Absolutely.
So let's move on to because it is again my favorite topic, and we can do it this one for hours. But one of the things I really love, and I think you're in a great spot, is kind of confidential computing. This is a topic we haven't touched on at all on the podcast, so I'm excited about this. But the last mile of data / application security. Let's talk about this a little bit because I think you're in a really unique position. And let's just kind of explore it a bit. For those who aren't, really familiar with it, can you kind of like break this down and let's walk through it a little bit?
Absolutely. So let's start with the basics. Let's understand what is data security, and at the end of the day, there's sort of three aspects. There's data at rest, data in transit, and data in use.
Mhm.
So when we look at securing data throughout its entire life, data at rest, that's your full disk encryption, your file encryption. It's your standard stuff that we've been doing, BitLock or what have you, for years.
Yep.
Transport encryption, that's your network security protocols, your TLS, your IPsec, your VPNs. Again, well understood. As you said, the last mile is, okay, what about when data is actually being used on the system? So when it's being transacted upon, when it's in memory, when it's available to the application and exposed, because it's no longer encrypted on disk and it's not going over a network, it's now in the clear being worked on. How do I protect it there? And that's what confidential computing really targets. And it uses a technique that's an industry standard we call a trusted execution environment. It's an industry term. What that means is a secure environment for the data to live in memory. Now, what does it mean to be secure in memory? There's two main aspects and then a third piece of the puzzle. So the first is memory encryption. So from the CPU to memory, that data is being encrypted as it leaves the CPU and goes to the memory card or goes to your memory. It's being encrypted. So it stays, its life in memory is as encrypted data. Two, there are specific controls in the CPU itself that isolate that data and those memory accesses from the rest of the applications and OS and drivers and BIOS. So if I'm putting my data into this trusted execution environment, even if I have a compromised BIOS, malware running at the lowest possible level in software, in the BIOS level, in the firmware, because it's a CPU control that it can't get access to it.
Cool.
And then the last piece is what's called attestation. And the joke is, if I have data secure in the forest and no one knows, if I can't attest it, is it really secure? I know it's a terrible joke, but the idea is that how do you verify that your data is running in that kind of environment, or that environment is available for you to put your data, your secrets, your keys into? And that's where what attestation does is it takes a measurement, a quote as a digital signature that incorporates both the environment itself and the CPU it's on with a unique key that you can verify publicly. Say, yes, I'm running on a legitimate platform, and that this enclave, this trusted execution, is operational where my application and my data resides. And so those three pieces is what really forms confidential computing. Now, there's a couple different ways of doing it, and that really comes down to what we call your TCB, or your trusted control boundary. How big of a boundary, or how much stuff do I need to have in my control base? So the most basic form is total memory encryption. That's basically where everything, the entire operating system, the entire data set, every application is just encrypted to memory. All of memory is encrypted with one sort of key, one root key that's derived for all of that. And there's no separation. And that's good because that protects you from the rogue admin walking by and popping the DIMM and walking away, or someone putting a little probe and sort of trying to read the memory as it's flowing. So it protects against a certain level of attack. But it doesn't differentiate between applications and data, but it does protect you from those kind of, cold boot and some of those other kind of attacks. Then you go say, okay, I need to move up the stack more. I want to protect a container. I want to protect a VM. How do I protect a whole VM from every other VM? Think cloud environment. I want Coke to be protected from Pepsi. I want to be able to run in a cloud. I don't know who my tenants are. So then there's the Intel technology is called trusted domain extensions. The other vendors have other versions. Basically, it's a VM level protection. So your whole VM is in its own trusted execution environment. And then the most restrictive version is software guard extensions, SGX, which takes it a step further, and it's just an application and its data. So even within the OS, it's a small space where just that application and its data is in its own TE, and there's a control call gate between the rest of the app and that protected space. And you do that, give you an example. If you were going to run a web server, maybe you want to put your TLS stack in the enclave. Maybe you've got your DRM application, you want the keys in an enclave, or you're doing classified documents and you want the authentication and that document only be there, but the rest of the application is out. So there's a variety of use cases. The ease of use goes up as you go down to the more broad, but the security goes up. And you pick the one based on your risk model. Do you need, and the size. There's, like a domain extension can handle a terabyte or two of data and application code, whereas an enclave is maybe less. TME, it's all of memory. So it really depends on the risk profile, but these technologies are available today. They've been around for a number of years. They're in your cloud providers. All of the cloud providers have some form of confidential computing available to you today. Yeah. And what it does is it closes that last mile gap. How do I protect my data when it's being used in the environment, whether that is in a cloud where I have tenants that I don't know, or I'm trusting a cloud provider to protect my data? We trust them because we wrote a contract, but do we really trust? We want to protect it even with that. And this gives them a capability that they can provide their sense. We have nothing to do with your security. Your security is from the hardware up. We can attest it to you. And now you have the peace of mind to use your whatever secrets, whatever corporate trade secret IP, put it in there. And even the cloud provider isn't involved in your security. And that's a powerful thing, a message. And it's a really good risk mitigation when you look at adopting scale clouds and hybrid clouds and multi-clouds. But it also is important in places like the edge, where you don't have guards with guns and doors with locks. You've got a power distribution station sitting out, what's the security control there? A fence, a poorly maintained camera, and a locked, cabinet. Yeah. That's the security of those servers that are out there in the field. Putting these kind of technologies into those servers means that even if somebody were to get in, they wouldn't be able to get at your data. They could, take the system away and you'd have denial of service, but they couldn't access the important data. They couldn't change the application code. And so confidential computing is a very powerful tool for protecting your data that last mile, but it's also where your data is at. And that is another key thing to remember. As we go into this AI world and we're sharing data, we've got inferencing, and this sort of ties us back to our last topic. One of the really powerful uses of confidential computing over the last couple of years is to protect your AI. You spent millions of dollars training this model. How do I make sure I protect it and keep it from someone stealing my weights or changing my weights or stealing my data? Yeah. Putting it into a confidential computing trusted execution environment, I can now deploy that into the field, deploy that into the car, deploy that into the cloud, and maintain my control over that as it goes off and does, its wonderful things.
That's just super cool. There's no two ways about it. I know it's a little geeky, which I love. So it's just super cool. And so one of the kind of transitions, as you were talking about this, I couldn't help but think it ties back into kind of that you mentioned FIPS earlier, and I was like, you know what? That's a really great example of how the government was doing this early on, and now it's being used by industry, throughout, and it's kind of becoming a standard now, right? Which is fascinating because it's been decades, right? So it took a long time. What do you see now that the kind of the government is implementing that people might not actually, see for years or a decade, kind of along that kind of FIPS line?
It's a good question. And I would say that there's a couple things. The government is moving faster than industry because of the risk and the threat. I think we'd be remiss to not talk about post-quantum cryptography. Yes. That's probably the biggest topic right now in government with the upcoming mandates. So January 1st, 2027 is one of the first deadlines for national security systems that they must start procuring equipment and software and services that are PQC. It's going to be acquisition requirements. So that kicks the ball moving, although there's already been work done and people are already migrating. There's a hard line in the sand. And then 2030, 2031, and 2035 are these deadlines by which everything must be post-quantum. And we're seeing the US government is actually the most aggressive in its time frame because, like you said earlier, they're the largest attack. They're the most at risk for a nation state or some adversary eventually getting a quantum computer. Mm-hmm. And the thing that people don't understand, this is sort of why it's taking industry a little while to catch up on this. It's not about, when that computer goes online, suddenly now I'm insecure and now I've got to fix the problem. So if it's 20 years out, I've got 20 years to worry about it. There's a key problem with the post-quantum challenge is the harvest now, decrypt later. It's not that your data in 20 years will be compromised. It will. It's the data you're encrypting today that the adversaries are downloading off the internet, piping into a large data center of storage, and waiting for when that happens. So all the communications and all the data that's being transported or stored today that you want to keep protected long-term is going to be at risk at that future date. And so until you go to a post-quantum algorithm, they're going to be able to go back in time, if you will, and look at the data from 2024, 2022, whenever they started recording, and go and decrypt that in trivial amount of time. And that is the reason why the risk is so high. It's not, and again, no one knows exactly when the quantum computer that will be relevant to cryptography will be available to a nation state. Some say 5 years, some say 20 years. It honestly doesn't matter. It's whenever that happens, all the data going back in time to when somebody started recording that data is what's at risk. And that's one of the things the government is pushing hard on. The US government is pushing hard on it. I've seen numbers, the UK government's got a 2028 deadline. So everyone is pushing towards that. And you're finding industry is sort of trying to figure out what do they have to do. And one of the nice things is that the government's a big enough acquirer of hardware and software and operating systems and cloud services that because of their mandates, they're going to push all of those vendors to be post-quantum. So when financial services and healthcare and retail make the decision, okay, I'm going to make that the risk I'm going to spend money on this year, the industry will typically, the ecosystem of providers will have already figured out how to do that for the government. And so the products will be available. So they'll be able to ride those coattails of the federal government when they start to pull through. Now, I know financial services is actually tracking pretty well because they have a lot at risk because the keys that encrypt the credit cards and their cash transactions are long lived, and you don't want someone going back and then suddenly, same thing with the blockchain for crypto. You don't want someone going back in time and changing values and suddenly magically has lots of crypto in their wallet. Those are kinds of things you want to protect now,
Yeah.
and migrate to. So I think post quantum is one of the key areas the government is leading. The other area is on the, so it's called in the government space, we call these mission platforms. In the industry, we call it IoT or industrial IoT. Really, the difference is one is flying really fast in a plane or is on a boat, or one is, controlling the robots on a John Deere factory floor. Under the covers, a lot of the same technology is in both of those.
Mm-hmm.
And how do I protect that technology? And so making sure I have good, solid security, that's verified boot, verified firmware, being able to validate the networks, icing, micro segmentation, all the techniques that the government is applying to these advanced mission platforms. We're seeing that in a couple of years, you'll find all of the IoT and industrial IoT, the critical infrastructure, will be adopting those hardware and network and infrastructure security things that the government's been sort of a vanguard on. The good news is folks like NIST are publishing documents and guidance for the industry when they figure out that this is something they want to take advantage. So they're not just sort of like, oh, when the industry wakes up, they have to go ask. There's good documentation out there. The NIST has published sector-specific guidance. So there's healthcare device, there's mobile, what do you call it, vehicle guidance, industrial IoT, manufacturing guidance. They've been putting out guidance on how to protect those things based on what they've seen government do for a lot of the same infrastructure. And so we're seeing that's going to probably be another one. It's not going to be as sexy as post-quantum, but as we start moving to more automated, to AI, when you sort of hook it up to the controls, when the manufacturing floor is now fully automated, you want to protect that because things could go horribly wrong if it's not.
Yeah. Okay. And I couldn't agree more. I think that's both, those are great examples. I think I told you one of my new favorite things with Darktrace. Intel wise, what would you say is one of your new favorite things that you guys are working on that you can talk about, right? What is kind of like your favorite, kind of new favorite product or idea, whatever it is? What's got you excited?
It's a hard question because there's so much going on, but I'll
Right.
pick on two things that are exciting right now. So we announced it at CES a couple of weeks ago. So the Panther Lake processor, the Ultra Core 3, built on 18A. Okay, great. So from a technique perspective, that's really cool. It's on an 18A process node. But what does that mean? And really, I actually saw a demo of running, on a small form factor gaming device with that 18A processor, the latest video game. I swear it's like you're watching reality on 8K definition.
Wow.
Unbelievable. And by the way, running 12 other applications at the same time. So we had Word open, we had PowerPoint, we're doing Zoom call. It just rocked. So from a perspective of the computing power at your fingertips, it is game changer. Now, why is that really exciting? It's okay. Now add in AI on that device.
That's where it gets
Now let's talk government. I need to be able to do in theater battlefield management.
Mm-hmm.
I need to be able to simulate my environment with all the, I've got air support, I've got Navy, I've got drones, I've got men in the field, I've got women in the field, I got sensors. How do I get all that data in, look at my current situational awareness, plan a mission and execute and track it through? That would take racks of servers in the past. I can do that not just with the laptop, but with a, almost like looks like a gaming device. MSI Claw makes this game that I can actually do all of that in a handheld device in theater where I need it. So it's getting the warfighter the tools they need to be operational where they are. And by the way, oftentimes they don't have access to the cloud because they're in a denied environment. Yeah. So being able to be self-contained and fully operational is amazing powers. That I think is really exciting.
That's super exciting.
Not just for the gaming side, but for doing real business too.
Oh, absolutely.
Absolutely. So that's one that's really exciting. And I think the other innovation, and this is industry wide, we're all trending towards memory safe languages. And Intel is leading the charge of building technologies to make that not just happen, but to make it accelerated so that it is faster, so that when you use a memory safe language like Rust or what have you, it doesn't slow down the application. You don't get the performance impact of doing those extra steps. And I think that's, from a security perspective, again, not as sexy as AI and gaming, but in the future, when that is adopted, whole categories of attacks disappear.
That's right.
Not just, oh, we made it easier to detect. Those attacks stop working.
Yeah.
Period. End of story. That is a fundamental shift in the entire, sort of cat and mouse game we've all lived for the past, umpteen years fighting with the adversaries. When we can knock out entire categories of their attack techniques and their attack vectors, you push them to places that then are either very expensive or not as performant. These kind of attacks, the memory attacks, the manipulation attacks, and we did this already once with the control flow execution technology we introduced a number of years ago, where we eliminated ROP and JOP attacks.
Yeah.
Again, what does that mean? It's basically the misuse of legitimate code to do evil things. 60% of APTs at the time were using that technique. When you knock off that, take that out the knees, you actually do good for the entire industry. And I think that's one of the exciting things I'm looking forward to in the not too distant future, when we can get operational memory safe. And again, we have memory safe technologies today, but they're not the best, most performant, the easiest to use. When we get them operational and we get them performant, we change that dynamic between the adversaries, where they have to do work again and they have to spend money and they can't just use easy techniques. And we push them up the stack, where then it's easier to use your security tools to find them.
Yep. No, 100%. And those are both super exciting. I love that. Steve, I cannot thank you enough for coming on today. This is fantastic. I think we could do this for hours, because this has been like one of my favorite episodes of all time. This is fantastic.
Thank you.
Steve, so thanks again for coming on. But before we go, can you tell everybody where they can find out more about you and more about Intel Fed?
Sure thing. So the best place to find information about Intel Federal is to go to intel.com/public sector. And that will take you to our main page. And you can see the innovations, you can see the technologies, the use cases, and what we're doing to help governments and by proxy, the whole industry do better with computing. Find out more about what I'm up to. The best place to find me is on LinkedIn. It's SORRIN. So linkedin.com/Soren is where you'd find me.
Awesome. Well, thanks, Steve. Until next time.
Thank you.
Thanks for listening to the Cyber Business Podcast. We'll see you again next time, and be sure to click subscribe to get future episodes.